Hi guys, this is your favorite math teacher, and today we are going to continue with Formula 2, that's second theory. The last time we ended at the property 3, and you can go to my YouTube channel, that's DKA Math Tutorial, to check so that you can update yourself. Now today we are going to continue with the property 4. So, what does the property 4 says? Property 4. What does the property 4 say? The property 4 says that when we have a circle like this, when you have a circle, and within the circle you have a quadrilateral figure. So let's label it as A, B, C, and D. So when you have a circle, and within a circle you have a quadrilateral figure. The property 4 says that, so let's say we have the angles being labeled, let's say alpha, maybe beta, and we have, let's say x, and what? Y. All that property 4 is saying that when you have a circle, and within the circle you have a four-sided figure or a quadrilateral figure, the sum of two opposite interior angles, the sum of two opposite interior angles add up to what? 180 degrees. The sum of what? Two opposite interior angles. So as you can see, the angle here, that's alpha, is opposite what? The angle what? Beta. And as you also can see that the angle what? Y is opposite what? Angle x. So we can therefore say that the angle D is the angle DAC, which is equal to alpha, and then the angle DCB, which is equal to beta. Since this angle alpha here is opposite the angle beta, there's some. So as I was saying, angle DAB. Okay, sorry, and I will see here. So it's angle DAB. Then angle DCB. So since the angle DAB, which is what? Equal to alpha. Then we have angle DCB, which is what? Beta. Since the angle alpha is opposite the what? The angle beta, the sum of these two angles give a sum up to what? 180. So you can therefore say that the angle DAB plus the angle DCB add up to 180 degrees. Therefore, we can conclude by saying that, or we can substitute those angles there by saying that the angle alpha plus the angle beta equals what? 180 degrees. You can also read from the diagram that the angle ADC. So from the diagram, you can see the angle ADC. So ABC, which is ABC, so which is what? Y. And the angle ABC. And angle ABC, which is equal to, which also is what? X. The angle is X. Since the angle X is opposite what? Angle Y, the sum of these two angles give us what? 180, or sum up to what? 180. Therefore, we can conclude by saying that the angle ABC plus angle ABC equals to 180 degrees. So it's equal to, or which amounts to y plus x equals to 180 degrees. So that's all about the property 4. That's all about the property 4. Now we move on to the property 5. We move on to the 5th property. So the property 5. What does the property 5 says? So property 5 says that when we have a circle and a radius and at the same time a tangent line, wherever the radius and the tangent line meet, subtends an angle of what? 90 degrees. Please note different textbooks and the way they arrange their properties. But all that you need to know is to get the idea. Are you okay? So maybe my property 4 might be some textbooks, maybe property 5 or 3. So it might not be in order as compared to the other textbooks that you have been reading from. So the property 5 says if I have a circle like this, and there's a center, and you know that from the center to any part of the circle is what? The distance from the center to any part of the circle is our what? Radius. So let's assume we have a radius here. So from the circle we have indicated that there's a center, and there's a line from the center to the what? Circumference, which is our radius. And we also have a tangent line. So if you don't know a tangent line, if you visit our previous video on the circle theory, you get to know what a tangent line is. A tangent line is simply a line that touches the circle, that's passing through the circle. So let's assume we have the tangent line labeled A, let's say C. So a tangent line meeting the radius at the point B. And what that the property is saying is that wherever the radius and the tangents meet, they form, or they subtend what? An angle of what? 90 degrees. So meaning you can therefore say that here is what? 90 degrees. You can also say that here also is what? 90 degrees. So therefore you can conclude by saying that angle ABO is equal to 90 degrees. We can also read by saying that angle CB also is what? 90 degrees. The angle CBO is also what? 90 degrees. So that's all about the property 5. So now we move on to the property 6. We move on to property 6. Let's move on to the property 6. What does the property 6 is? It says when you have a circle like this, and there's a diameter, and there's a what? A diameter. So you know that the diameter also divides the circle into 2 equal parts. So once you have a diameter, you should have a center. So the angle the diameter sustains at any part of the circumference is what? 90 degrees. The angle that this diameter sustains at any part of the circumference is what? 90 degrees. So this is how it is. So you see we have this diameter sustaining an angle here. And this angle is what? 90 degrees. So let's label this A, B, let's say C. So under the property says that since this one is a diameter, and this diameter is sustaining an angle at the circumference, then that angle sustaining at the circumference was 90 degrees. You can still have another angle here. Since this same diameter is still sustaining the same, is sustaining another angle here. Since this angle is forming from the diameter, meaning the angle here also is what? 90 degrees. So let's label this one as, let's say, M. So we can therefore conclude by saying that since A line AB is a diameter, since line AB is a diameter, then the angle sustained by this diameter at the various circumference add up to us 90 degrees. Therefore, we can say that angle ACB is equal to 90 degrees. Then angle AMB also 90 degrees. Now there's another property that also supports this. Now I think that was the property 2. What does the property say? The property 2 says. It says the angle sustains at opposite segment by the same chord. The angle chord sustains at opposite segments add up towards 180 degrees. And the diameter also is a special chord. It's a special chord. So this one is a special chord, meaning it's a chord. And this same chord is sustaining an angle at opposite what? Segment. You have one segment here, you have another segment here. So as you can see, the angle sustained by the same chord at opposite segment add up to 180. So we can therefore say that if you see the angle here, is what? AC, that's what we have here. And then at the different segments, we have angle what? AMB. So which is this? So the sum of these different segments formed by what? The same what? Chord. Add up to 180. If we can say that angle ACB plus angle AMB equals what? 180 degrees. Therefore, it is 90 degrees plus 90 degrees. This is what? 180 degrees. So which this angle also, or which this property has also what? Supports the property what? 2. So if you are forgetting that one, kindly remind yourself by visiting the previous video on circuit theory to remind yourself. Now, you then move on to the property 7. So what does the property 7 says? We are moving on to property 7. We are moving on to property 7. So property 7 says that when we have a circle like this, and within a circle we maybe have 3-sided figure. We have a 3-sided figure like this. So let's see this. So within this, we have a circle, and within the circle, we have a 3-sided figure. So let's label it, let's say A, B, C. And let's name the angles. Let's say we have angle I, angle X, let's say Y. Then there's a tangent line. There's a tangent line. What does this property say? They said the angle formed, or the angle a chord in a tangent sustains. The angle what? A chord, as you know, this is a chord because this line does not divide the circle into two what? Equal parts. So the angle a chord, and this is a tangent line, as I told you, a tangent line is a line that touches the circle but does not what? Pass through the what? Circle. So the angle a chord, this chord, and the tangent sustain is equal to the angle the chord is forming at the opposite or at the alternate what? Segments. The angle a chord, so this is the chord, and the tangent makes is equal to the angle that same chord is sustaining at the what? Opposite what? Segment. So as you can see, this chord is sustaining the angle with the tangent, let's say V. So the angle this chord is sustaining here is V. So the chord and the tangent sustains an angle V. And they said this angle is equal to the angle this chord is sustaining at the opposite segment. So we have one segment here, and this same chord is forming an angle at the opposite segments. So therefore we can conclude by saying that, let's say this one is T, because it's a tangent. So we can say that angle X, because this is the chord that is forming an angle V with the tangent, and this same chord is also sustaining an angle at the opposite segment. Therefore, we can say that the angle X is equal to angle what? V. Assuming we have another tangent line here. So let's assume we have a tangent line here. And you see a chord, there's a chord here. So this is a chord. This is a chord, this is a tangent. And the chord and the tangent is making an angle of, let's say, M, or let's say N. It's forming an angle of what? N. He said the angle the chord and the tangent mix is equal to the angle the chord is sustaining at the opposite segment. This is the chord, and this chord here is forming an angle at the opposite segment, which is what? Y. Therefore, we can conclude by saying that the angle N is equal to the angle what? Y. Because somebody also can have it somewhere here, so we can have a tangent line here. And the tangent and this chord may be forming an angle, let's say U. It's forming an angle U. Now, what will be this U be equal to which angle? They said it should be equal to X, YX, because this is the tangent and it's forming an angle with this chord, which is U, and this same chord so sustaining an angle at the opposite segment, which is what? X. Therefore, we can conclude by saying that the angle U is equal to the angle what? X. So that's all about the property 7. So kindly sit down, listen, and note the angles. Now we move on to the property 8. So we move on to the property 8. So we move on to the 8th property. And what does the 8th property says? Is that when you have a circle, like this, and within the circle, we have a quadrilateral figure, four-sided figure within. So let's say we have four-sided figure here. So this is a figure here we have. So we have a circle we have a quadrilateral figure within the circle. What does this property say? They said if there is a target line at any point, if there is a target line, what we did first, when you have, this one was a three-sided figure. When you have three-sided figure, how to determine the what angle, or which angle is equal to the what? The angles within the what? Triangle, or the triangular what figure. Now this is a quadrilateral figure. This is a quadrilateral four-sided figure. Now, all these properties, so let's label this A, B, C, let's say D. Then this is a tangents. Let's label the angles, let's say I. Let's label this X. Let's label this one Y. And let's label this one V. So if you have this, the property says that the interior angle within a cyclic quadrilateral, listen, the interior angle within a cyclic quadrilateral is equal to the angle formed by the what? Exterior angle. So the interior angle of a circle, so these are the interior angles within four-sided figure. Interior angles within what? A cyclic what? So this is a cycle. And we have a quadrilateral figure. So we say the interior angle within a cyclic quadrilateral figure is equal to the opposite what? Exterior angle. So let's take this one. As you can see, we have a tangent or an exterior angle here. So let's say we have an exterior angle. It's outside the figure. It's outside the what? The four-sided figure. So it's an exterior angle. Are you okay? So let's label that one as, let's say, N. They said the interior angles within a cyclic quadrilateral is equal to the exterior angle. Are you okay? Of that what? Cyclic quadrilateral. So this is an interior angle. It is found within the four-sided figure. This angle is equal to what? Its opposite what? Exterior what? Angle. Therefore, we can conclude by saying that the angle X here is equal to the what? The angle N. Let us assume we have another exterior angle here, have another one here, we have another one here. So this one is, let's say, N. This one, let's say P. Then this one will be maybe Z. Therefore, the interior angle, we check the interior angle. So let's say if we take I, this I is which exterior angle is it opposite to? This is an exterior angle. This is an exterior angle, this is an exterior angle. But as you can see, this eye is opposite to this one, exterior angle here. Therefore, we can conclude by saying that they said the property says what? The interior angle within a cyclic quadrilateral is equal to its opposite what? Exterior what? Angle. Therefore, we can conclude by saying that the angle I is equal to the angle M. Which angle also? Can you see? As you can see that this Y is opposite, which is interior angle, which is found within the quadrilateral figure. It's opposite to what this was exterior what? Angle. Therefore, we can say that the angle Y is also equal to the exterior angle, which is what? Angle P. Then we can also say that the interior angle V is opposite to the exterior angle what? Z. So therefore, we can say that the angle V here is equal to opposite exterior what? Angle, which is what? Angle Z. So that's all about this property. That's all about this property. So this property is saying that the interior angles within a cyclic quadrilateral is opposite what? It's what? Exterior what? Angles. So that's all. Now, we move on to the last property. For my own, or for my dictionary, or for my textbook, I call it the last property. It can be somebody's textbook or somebody's lessons property 5, property 4. That now let's remind ourselves very quick, real quick. There's a triangle, a type of a triangle you have learned that it's isosceles triangle. Now what does the isosceles triangle say? Isosceles triangle has two of its sides to what? Equal. So let's assume you have an isosceles triangle here, and sometimes it will be indicated something like this, telling you that the line here are equal. So if the measurement of this is 5 meters, here also was 5 meters. I don't know. So it depends. So it will be indicated. Sometimes it will take twice, telling that these lines are equal. Now, what the isosceles triangle is trying to tell us that whenever you have a triangle which is isosceles and you have two of its sides to be equal, then two of its angles also be what? Equal. Are you okay? So if here is x and here is y, since it is an isosceles triangle with two sides to be equal, the angles also formed by those lines are also what? Equal. Therefore, we can say that the angle y is equal to what? The angle x. Now, let's go back to what the property 9 is. With this same idea, so let me draw it somewhere here. So therefore, we can see that x is equal to y. Now the property is saying, what this property is saying. Because when you have a circle and there's a center, a circle with a center, let's say O. And as you know, from the center to any part of the circle is what? It's a radius. So we may have here to be our what? From the center to any part of the circle is radius. So let's have another one here. Also it's a radius. So if this radius are formed by, let's say, this is an arc, meaning the angle formed on those arcs are equal. Or you can set aside the chord. So the meaning, since sometimes the question shouldn't specify it for you that this one is a radius, but since you know that these lines are moving from the center to any part of the circle, you should know by yourself that since from the center of the circle to any part of the circle is a radius, so automatically without indicating that this one and this one are equal, you should know by yourself that from the center to any part of the circle is what? Equal. Are you okay? Which is a radius. Therefore, the angle formed by those radius are also equal. So if you have, let's say, sometimes in the exams you see another line being projected like this, and it will be indicated like this. It will be indicated for you like this. Automatically, even though these lines are not radius, but they are still telling you that since this line and this line are equal, then the angle formed by this line to the chord are also equal. So we can therefore say that, let's label A, B, then here to be C. We can therefore say that if here is, let's say, I, and this side to be, let's say, U, and the whole of this is M, and the whole of this is, let's say, n. Therefore, we can conclude by saying that since this line and this line are radius, then the angle formed by them at the circumference joining by the same chord are what? Equal. Then we can therefore conclude by saying that the angle I is equal to what? The angle what? U. We can also say that since this line AC, so you can see that line AC is also equal to line AB. Since they are equal, then the angle formed by them and the circumference joining by the what? Same chord are also what? Equal. Then we can say that the angle N is also equal to the angle M. So that's all you need to know about the ninth property. The ninth property. So that will be the property 9. That property has where by the way we get this and it becomes x. Ix, which is the ninth property. So we can either write 9 there or Ix like this. So not this x, so Ix like this. So that's the ninth property. And we know as usual, there's a property that supports this one, and there's no need. That the angle sustained at the circumference is twice the angle sustained at the center of the circle. If you have forgotten, kindly visit the previous video on the circle theory, part 1. Or is it part? Yes, part 1. Yes. And revise. Then this is where we end this session. The next time we meet, we'll be solving questions on it. We'll be taking exams questions, past questions on circuit theory. So far, we are finished, or we are done, or we are through with the properties. The next time we meet, we'll be solving questions here. So, if you have not subscribed to the channel, kindly subscribe by search or by typing DKA Maths Tutorial and share the content for people to see. Thank you.